Number 15 from the homework says the total number of local maximum and minimum points of the function whose derivative of all x is given by the derivative f prime equals x minus 3 squared x plus 1 to the power 4. So I've rewritten the derivative down here in green. And based on the factored form, we have zeros for the derivative at -1, 0, and 3. So what we're going to do then is just test the slopes in those regions. So testing the slope on the left of -1, we're going to test it at -2. Now looking at the derivative, since this factor here and this factor here are even powered factors, the sign of this derivative is just dependent on x. So here the slope of that is going to be negative, so we know it's going down like this. We have 0 slope here. At -0.5, it's going to be negative, so in between -1 and 0, it's going to be pointing down. Between 0 and 3, we've chosen 1, so it's +1, so it's going to be positive slope, so it's going to be going up. And at 4, it's positive, so it's going to be going up as well. So the only point that we actually have a change in slope is going to be through here. So this is the only part that says change in slope. There's only one local minimum. So the answer is going to be B. If we were to sketch this graph, we want to know what this graph looks like, we can kind of sketch it like this. We know that at -1, it has a 0 slope, but it has a multiplicity of 4. So it's going to be kind of flat through there. It's going to have a minimum point through here. When it hits x equals 3, it's going to slide through there like this. So it's going to have kind of graph that's going to have that kind of shape.